Welcome back, student, to the class Design and Analysis of Algorithm. Today we are going to see uh, performance analysis of algorithm, and we are going to see the space complexity, and we are going to see the time complexity, and the last one is measures of time complexity. How we are going to measure time complexity. So before going to start this lecture, I am going to tell you performance analysis of algorithm is one of the most important topic in this. And in performance analysis of algorithm, we will going to have the space complexity and time complexity. All the 5 unit is based on this space complexity and time complexity. How much space is needed for the program and how much time is needed to solve the problem or to complete the program. So this is very important topic, and let's see one by one. So here, performance analysis of algorithm, the first one is correctness. Okay, the performance analysis of algorithm, following criteria are considered. These are the criterias. 5 criterias are there. We will see one by one, and the first one is correctness. What is the correctness? The algorithm must be capable of solving the problem correctly. Example, if you are doing the addition of two numbers, so till the program finish you must do only addition. You should not mix up like multiplication or division or something like that. When you are solving the problem of addition of two numbers, so until it is completed, till that you need to do the same. Okay, so there is nothing but correctness. Simplicity. An algorithm must be simple enough so that programmer can easily verify its correctness and also write, debug and modify it easily. Means when you are writing the algorithm, your program should be easy. There should not be a difficult for the programmer, those who wants to edit it or write or debug. Okay, the simplicity is also very important. Readability. The code defined in the algorithm must be readable, otherwise it will be a difficult to understand, it's very difficult to debug, it's very difficult to modify the data. Fourth one is the time complexity. Time complexity of an algorithm must be less. Whenever we are solving any problem, we will like we want that should be take very less time. Okay, the algorithm must consume less time for executing a task. If we are taking the addition of two number, we want very fast. Space complexity. Space complexity of an algorithm must be low. It take the less memory and it should be work fast. Okay, the algorithm must consume less storage. These 5 are the performance analysis of algorithm, and this is very important. Okay, correctness, simplicity, readability, time complexity and space complexity. Now we will see the space complexity. Space complexity, the total amount of computer memory required by an algorithm to complete its execution is called a space complexity of that algorithm. Means whatever the memory is needed to solve that problem, that is called space complexity. So where we can do this? For any algorithm, memory is required for the following purpose. Memory required to store program instructions, whatever the instructions you have, instruction or statements. Okay, like int I. Okay, there is also a one type of instruction or statement. Memory required, the second one is memory required to store constant value. Sometime we will give the constant value that will never change. Constant value is also known as fixed value. If we are giving the 10 in a program, so till the end it will be 10 only. Okay, memory required to store variable value. In the variable value, whatever the variable value, every time the program execute, the value will be changed. Every time the value will be changed. And for other things, so these are the basic things. For that we need a memory to program instruction, for a constant value, for a variable value, and then other things like array and all the things. Okay, so this is a space complexity definition. Here, how will you calculate the space complexity? This is a question. That calculate the space complexity, we must know the memory required to store different data type values. Like example, C programming language compiler required the following data type. Means if we consider the C programming based on that data type, integer will take the 2 bytes, floating point is taking 4 byte, character is taking 1 byte, stored double is taking 6 or 8. So when we define this data type, based on that we can say which data type is taking how much memory. Okay, if we have written int a is here is 2 bytes, so we can say 2 byte. If we are taking float, then it will take the 4 byte. So like this we are taking the example in the whole space complexity, as well as in the space complexity we are going to take the data base, data type is this C data type. Okay, okay, in this two things are there. Space complexity, as we have discussed, two things are there. One is constant, another one is variable. So here constant, like fixed part and variable part, these two things are very important, and these two can be applied in the space complexity. A fixed part, that is the space required to store certain data and variable that are independent of the size of a problem. For example, simple variable and constant use program size, etc. Means if we have given like a is equals to 10, b is equals to 10 something, so that is called fixed part. Means that is independent, that is not depending on anyone. Okay, and what is a variable part? Variable part is a space required by variable whose size is depend on a size of a problem. For example, dynamic memory allocation, recursion stack space, etc. Here, like if we have written like for is if we are writing uh, let me here example, if I am writing I less than 5, sorry, uh, here not I less than, let me correct this, I less than n, I less than n. So these are the dependent. I value is depending on 5. 5 will, sorry, n. N will be 5, 10, anything. So this is dependent variable. So this is called variable part. And here in the fixed part, if it is a is equals to 10, then finish. It is independent, it is not depending on anyone. But here I less than n means it both are dependent. Okay, so these are the variable part, the example of variable part. Okay, so this the two things are there in the space complexity. Okay, for the space complexity we have a formula. Space S of p of an algorithm, okay, is S of p is equals to C plus S base p of I, where C is the fixed part. C is a fixed part, means constant, and S of I is a variable part of an algorithm. S of I means this, okay, is a part of a variable which depend on instance characteristics with I instance characteristics. Following is a simple example that tries to explain the concept. Okay, we will take a small example for understanding purpose. This will implement in that program. So take addition of two numbers, algorithm sum a comma b. Step 2, c is equals to a plus b plus 10. This is c, constant. Stop. Okay, so here we have written a simple algorithm for sum a comma b. So how many variables we have? 1, 2, 3. Okay, and this here we have three variable a, b and c and one constant. Hence s of p is equals to 3 plus 1. Okay, three variable plus one constant, or you can write here 1 plus 3, one constant plus 3. How do you want to write? You can write. So now space depend on data type of given variable and constant type, and it will be multiplied accordingly. So this is a simple answer, and what the answer we are getting? We are getting the answer 4. We are getting the answer 4. 4 is a constant. So this is a constant. If we are getting the constant value, then your result is perfect, means best result if you are getting the constant value. So this is space complexity. We will take another example. So take the here the piece of code, int square of int a and return a star a. So here we are defining a int. We are defining here int. Int means, as we have discussed, int will take the 2 bytes. So in the above piece of code, it required 2 bytes of memory to store a variable a, and another 2 byte of memory is used for returning the value. When it is taking the int, then you must return. So for whatever the amount of memory is taking by the declaring, okay, that the same amount of memory will take for the return, because we are returning for the same data type. Sorry, so that is 2 and 2, 4, 4 byte. So that means the total is required 4 byte of memory to complete the execution, and this 4 byte of memory is fixed for any input value of a. The space complexity is said to be a constant space complexity. That means if the a value is changed here, any number of 5, okay, 6, any number 60, 70, any number of any input value of this a, but the space is required the same thing. So that is called constant space complexity. So what is the definition of constant space complexity? If an algorithm required a fixed amount of space for all input values, then the space complexity is said to be constant space complexity. So this is a one example, and we are getting the constant space complexity. So let me see the next example. Consider here int sum of int of a of array int n. Here we are using the array. Int sum is equals to 0 of I for I is equals to 0, I less than n, I plus plus. So this is a simple example. Sum is equals to sum plus a of I, return sum. So here how much space is taking in in above piece of code, n into 2 n star byte of memory to store the array variable a of array. So how much memory is needed? N, because I less than n. So this is a dependent. So this is a variable part, I less than n. So I is depend on n. So how much time it needed? N time. And 2 byte of memory for the integer parameter n. How much time is taking by this? N. And what is the n? Is n. Okay, so how many n we have? 2n. And 4 bytes of memory for local variable sum and I. Here we are declaring the variable, that is sum and I. Okay, and 2 bytes of memory for returning the value. For returning this value we need a 2, because int will take the 2 bytes. So sum is 2 byte, I is 2 byte. So 4 is here, and for returning the sum we have 2. Okay, and we have a n is for 2 bytes. So what will be the answer for this? That means totally the required 2n plus 4 2s are 8. 4 2s are 8. 8 bytes of memory to complete its execution. So what is the total time is taking? 2n plus 8. Whatever the n value will be there, that will be multiply. If here the n value is 2, so 2 2s are 4. 4 plus 8 is 12. So our time is 12. So based on the n value, we will get the space. So here the amount of memory depend on the input value of m. As I told you, it's depend on a n. This space complexity is said to be a linear space complexity. When we will say the linear space complexity, if the amount of space required by an algorithm is increased with the increase of input value, then that space complexity is said to be a linear. Okay, so this is the two example we have completed, constant and for the linear. So this is about the space complexity. Now we will move to the next topic, that is space complexity. The time complexity. The time complexity of an algorithm is the total amount of time required by an algorithm is complete its execution. So how much time is taking to complete the execution, that is called time complexity. This is also very important. Here when we will check, generally running time of an algorithm depend upon the following. If these are the some of the points, based on this we will get the time. Whether it is a running on a single processor machine or multiprocessor machine. The first point, if we have a single processor machine, it will little bit slow. If you have a multiprocessor machine, then your time will be fast. You can complete the task very fast. And based on the machine also, whether it is a 32-bit machine or 64-bit machine, like we can say the operating system is 32-bit, 64-bit. In the same way, the machine, it should be uh, based on the machine. We will say what is the time, 32-bit machine or 64-bit machine. Read and write speed of the machine, what is the capacity of read and write machine. The time is taken to perform arithmetic operation, logical operation, return value, an assignment operator, etc. How much time it's taking, performance. Based on that performance, we can tell the time. And the last one is input data, rate of growth of time with respect to input. How much input you are giving, based on that the time will be vary. So these are the things are there. We have to depend, the time will be depend on this of these are the things. But we will take one example and we will consider one machine in, I will show you. Based on that we will solve. To calculate time complexity of an algorithm, we need to define a model machine. Let us assume a machine for the following configuration. So we are discussing here 32 or 64 writing speed and single process processor. So we are assuming the machine. First one is a single processor machine, 32-bit operating system machine. It performs sequential execution, is linear. It required 1 unit of time for arithmetic and logical operation. So we are assuming this. Okay, we are assuming this machine, and based on this we will find the time complexity. And the fifth one is it required 1 unit of time for assignment and return value, and it required 1 unit of time for read and write operation. So what we are telling, 1 unit, we is up to you, but we are mentioning 1 unit of time for arithmetic and logical, 1 unit of time for assignment and return value, 1 unit of time for read and write. So we will do the example. Consider the following piece of code. First one, addition of two numbers, so that is int sum, int a comma int b, return a plus b. So this is a simple code. This is a simple code. Now we need to check what is the time complexity of it. In above simple code, it required 1 unit of time to calculate a plus b. A plus b, how much time it needed? 1. 1 unit of time. And 1 unit of time to return the value. Sorry, yes, calculating and returning 1 means plus 1. That means total it's taking 2 unit of time to complete it execution, and it does not change based on the input value of a and b. That means for all input value it required the same amount of time. If the here whatever the a or b value, it doesn't matter, whatever the value like 100, 200, 500, 5, 4, 6, any number, a and b, any number, but time taken only 1 unit of time. So what will be the total time for the given algorithm is 2 unit of time. Okay, so this is a simple example. Let's take the another example. Here consider the following piece of code. Same code, what code we have used for the space complexity, the same code we are using here for the time complexity. Int sum, int a of array, int n, and here int sum is equals to 0 and I, for I is equals to 0, I less than n, I plus plus, sum is equals to sum plus a of I, and return sum. So here we define the same code, this code here, and we are explaining one by one. Int sum is equals to 0 or I. So this is declaring, and it will take a 1 unit of time. And for I is equals to 0, I less than n, I plus plus. So for this I is equals to 0 is taking 1, I less than 1, for checking the condition it's taking 1, and I plus plus is checking for incrementing is 1. Sum is equals to sum plus a of I is taking, for this is 1 and this is 1, so total 2. And the last one is return sum. For returning the value is taking 1 unit of time. Okay, so this is a cost, means it's for single line, means one time if it is execute a single line, this is a cost. But here repetition is there. Here checking the condition 0 less than 5, example 0 less than 5, checking condition, going back, checking condition, go back. Okay, so for that we need to check the repetition also. So in the repetition, first one is it will execute only first time, so it will take the 1 unit of time. And here first one I is equal to 0, how many time it will execute? Only one time. Okay, so that is 1. I less than n, how many time it will check 1 less than n? Means every time it will be execute, like example n is equals to 2, example. So here we are condition checking 0 less than 2. Okay, 1, then I plus plus, 1 less than 2. Okay, okay, the next I plus plus, 2 less than 2. Wrong. That means I less than n, how many time it will be execute? It will execute n plus 1 time. That means whatever the n value, because we need to false the condition. For falsing the condition, you must reach more than one step of the n, so that is n plus 1. So what is the value we have taken here? 2, 1 and 2, then plus 1, so what is the value? 3. So here in the third time it is not executing, but the condition is checking n plus 1 time. So because of that we have written here n plus 1. And how many time it is increasing? How many time it is increasing? N time. Okay, and it is increasing by n time. How it is increasing? First initializing I is equals to 0 is from here, then it is increasing one time, 1, then again it is increasing, here it is 2, I plus plus. So this is increasing 2 time, and why, if it is increasing 2 time and our n value is also 2 time, so that is n. And sum is equals to sum plus a of I, how many time it will be execute? Until when the condition falls, it will out from the loop. Okay, so until how many time it will be execute? It will execute the n number of time it will execute, and this statement will display n number of time, and at the last return will take only 1. Okay, and what is the total amount of this? What is the total? 1 is 1, and here 2n plus 2, 2n plus 2, and here 2n, 2n, and here 1. So this is a 2n plus 2. So 1, 2n plus 2, 2n, and 1. What is the total? 4n plus 4. Okay, so this is a time taken, and 4n plus 4. I hope you understand this. Okay, this is for the line and this is for the repetition. When we multiply this both, we will get this result, the total amount, and this total we are doing the addition, then we are getting the 4n plus 4 for this program. So here in above calculation, like this calculation, whatever the calculations are there, based on that, cost is the amount of computer time required for a single operation in each line. What is this cost? Cost is the amount of computer time required for a single operation, for the single operation. What is the repetition? Is the amount of computer time required for each operation for all the representation. Sorry, repetition. Repetition is the amount of computer time required by each operation for all its repetition. How many time it is repeating, for that it is taking time. And the total amount of time required by each operation to execute. Each operation to execute. So above code required 4n plus 4 unit of computer time to complete the task. Here the exact time is not fixed and it change based on the n value, because here the n and the value will be changed based on the n value. If we increase the n value, then the time required also increase linearly. So total is time for n plus 4 unit of time of complete its execution, and it is linear time complexity. If the amount of time required by an algorithm is increased with the increase of input value, then that time complexity is said to be linear time complexity. I hope you understand this. Based on this, the cost is for a single operation, and repetition is for the each operation for all the repetition. Then total is the amount of computer time required by each operation to execute. So now we will move to the next topic, that is measure of time complexity. In the measure of time complexity, is the first one is best. The amount of time the algorithm take on a best set of inputs. Inputs are provided in such a way that minimum time is required to process time, that is fast time to complete with optimal input choice chosen. Okay, first is the best, if it is completing on the best time. Okay, and minimum time it is taking, then it will be a best. Next one is worst. The amount of time the algorithm takes on worst possible set of inputs. It is the slowest time to complete with bad input chosen. Okay, pessimal is nothing but is a bad or worst. BAD. Okay, this is a worst. Next, average case, the amount of time the algorithm takes on average set of inputs. The average case complexity of algorithm is the function defined by the average number of steps taken on an instance of size n. Okay, so this is average. It will be not a worst and not a best. So whatever the time is in the average minimum, like it is not taking much time, then this is a average case. And the last one is the input size. The running time of a program can be expressed as a function of size of the input. The size of input is typically denoted as n, and the running time of algorithm is t of n. So we will see the graph here. Best case means it should be complete in minimum number of time. Average means it will be in the middle of best and worst case. And this is a worst case, is taking number of steps more and size is also more. So this is the measure of time complexity. So what we have done today: performance analysis of algorithm, space complexity, time complexity, and measures of time complexity. These are the things we have completed today. In the next lecture we will going to see the asymptotic notation, and we will see all the like constant, linear, exponential. This all the things we are going to see in the next class. In the next class we are going to see asymptotic notation. That is important. Asymptotic notation, only with the help of asymptotic notation we are able to find the space complexity and time complexity. So for the today we have completed this. Thank you. We'll see you in the next class.